Hey, the purpose of this section is to talk about the Azure Load Balancer and also show you a quick demo of deploying a public-facing Azure Load Balancer. So let's briefly look into what is Azure Load Balancer is all about. So Azure Load Balancer operates at a layer 4 of the open systems interconnection model. So it's a single point of contact for clients. Load Balancer also distributes the incoming flows that arrive at the load balancer front end to back and pool instances. So these flows are according to a configured load balancing rules and health probes, which we will see in the demo. The back and pool instances can be a virtual machine or a virtual machine scale set. There are two types of SKUs within the load balancer, which is the first one is called the basic and the standard. The basic load balancer is offered at no charge. And also one other thing I'd notice about the basic load balancer is it's open to internet by default. The basic load balancer relies on network security groups or virtual appliances to secure the virtual machines. The standard tier is secured by default and requires network security groups to explicitly permit traffic through a public IP address. In our example, we will deploy a standard load balancer, and we also configure an SG. The SLA of the basic load balancer is implied in the virtual machine SLA, and that depends on how you deploy the virtual machines. The standard tier has got its own SLA, which is 4 nines, 99.99%, matching the highest virtual machine SLA. Additionally, there's a feature called HA ports. In the scenario of network virtual appliances, the basic tier normally provides only active-passive solution with virtual firewalls. HA ports, a feature of the standard tier, enables virtual firewalls to become active-active, and this provides the ability to scale out for higher traffic deployments. Additionally, we also look into automatic reconfiguration. What we mean by automatic reconfiguration is the load balancer, based on the back and pool health, it will automatically distribute traffic to only healthy virtual machine or a virtual machine scale set, and that also gets your application in high availability, where if one of the machines are down, it doesn't matter, the traffic could be routed to the other healthier machines. And the traffic distribution rules is it's a hash-based distribution model of 5 tuples: source IP, source port, destination IP, destination port, and protocol type. So in that scenario, what happens is the Azure load balancer will use the hashing algorithm for distribution of the inbound flows. The load balancer rewrites the header of the flows to the backend pool instances. A server is available to receive the new flows when the health probe indicates the healthy backend endpoint. By default, the load balancer uses a 5 tuple hash. And there is also two options of the load balancer. One is you can have an internal only facing load balancer or a public facing load balancers. Next, we come to the backend probes. So when you're using the load balancer rules with the Azure load balancer, you need to specify health probes to allow the load balancer to detect the backend endpoint status. The configuration of the health probe and the probe responses determine which backend pool instances will receive the new flows. You can use health probes to detect failures of an application on a backend endpoint. You can also generate a custom response to a health probe and use health probe for flow control to manage load and plan downtime. When a health probe fails, the load balancer will stop sending new flows to the respective unhealthy instances. By the way, outbound connectivity is not impacted, only the inbound connectivity is impacted. In our example, we will showcase how to use the health probes and also set you some duration as well as of availability, so you can actually do a test case on it. Do also note there is also The health probe supports TCP, HTTP, HTTPS. The basics queue only supports TCP and HTTP. Additionally, the last point, monitoring. Azure Load Balancer supports log analytics, app insights, and also the control plane and management plane logging and audit. In summary, there are 4 key points to remember about the load balancer. So first and foremost, the application protocols supported by Azure Load Balancer are basically TCP, UDP, HTTP, and HTTPS. And endpoint and monitoring is provided via probes. It also supports VNet. You can have both internal and external facing applications supported through VNet, endpoints. The virtual machine, the type of endpoints that supported are virtual machines or a virtual machine scale set. I really want to quickly go through the demo flow that we will be using today. We'll be using Azure CLI to deploy the Azure Load Balancer. A couple of things here to notice. First and foremost, we will create a resource group to host the virtual network and the load balancer. We'll also create a public endpoint so that the end user that is available outside of your enterprise or outside of your network can reach that public endpoint. And we also configure a front end IP configuration that attach the IP address to the front end IP configuration. We also create a backend pool of servers. So these are the servers that is going to handle the workload that is coming from the external users. And we also create a couple of load balancing rules. So the load balancing rules, as we saw earlier, would help you take the traffic inflows and then distribute it according to the tuples configuration. On top of that, we also have a health probe that will monitor the port 80 at we have set up a 360-degree seconds interval and 5 probe count. What we mean by that is after 5 probe counts, if the instance is not returning any healthy status, that particular node would be taken out of rotation and the traffic will be routed to the available ones. Additionally, what we also do is we will create 3 virtual machines, and each of these virtual machines will be attached to a network interface card. Within the network interface card, we will be configuring a NSG, which is a network security group, that will allow only port 80 and port 3389. So because port 3389 is a very well-known port, we also do some NATing rules so that a different port address would be given to the port 3389, and these machines will also have a public IP address. So the reason for that is an administrator can log into the public IP address and RDP this into the virtual machines to do some updates and to showcase the sample. This is not necessary in a production type environment. For in our example, we're using a public IP to showcase how to use the RDP functionality of the virtual machine, and also go and change the couple of configurations for this demo. So this is a high-level overview of the demo. Next, we will go into the demo to showcase how this sample is going to work and how we are going to host a public public endpoint facing load balancer. I have the code ready in my Visual Studio Code. So I will walk you through the script. So we are starting with a resource group. The resource group is located in the East US. And we also create a public IP address. The public IP address would be exposed to public internet for the traffic to get the traffic. We'll also create a front-end IP configuration, the back-end IP configuration, and we also create a probe. As we spoke earlier, the probe would listen in port 80. The interval in seconds for the as well as the probe count to be 5, and we configure that the load balancing rule, and we also have a NAT configuration. NAT is basically to kind of the backend pool, the backend port of the virtual machines will be 3389, but it will be exposed as 4221. This is purely from a security perspective. because we're having three virtual machines, we're going to have three inbound NAT configuration. And in this case, after doing that, we will be creating an Azure load balancer. As you can see, the load balancer would have a front-end IP configuration as we configured earlier. It will also have probe. It will also inbound NAT rule for accessing this virtual machines. We also have a subnet that will be used. That's where these virtual machines would be hosted, and we will create a virtual network. And we also have public IP addresses for these three virtual machines. For in order to access the virtual machines from a public endpoint, we will be using these public endpoint IP addresses. We also configure NSG rule for port 3389 and also port 80. We have only two rules that these are basically called as network security group rules. These rules on this for this configuration will allow only the RDP and the HTTP. And then we create a network security group, and then we also create a network interface card for the three virtual machines. And once you do that, what we also do is we would configure three Windows 2019 Data Center Edition DS1 V2 type virtual machines. Once we create the virtual machines, in total we're going to create three. What we'll end up doing is we will go and RDP into those machines and install an IIS web server, so that you can actually reach these web servers in these machines through a public endpoint. In order to make it easier, we also change we have a IIS start.html page to point out to a simple message called hello world from the host, to showcase which host is currently in use, and it also helps you to showcase how the machines get rotated to handle the traffic. As we saw in the earlier introduction, the goal here is to create a public-facing load balancer. The backend pool of this public-facing load balancer would be a Windows IIS server. So these IIS server would be displaying a web page for the end user that is requesting the information from these web servers. It's a very simple to use case. So we will be using PowerShell to kickstart the deployment. Let's start with creating of a resource group. As you can see, the resource group got created, and next we will go and create a public facing IP address. So currently Azure is creating the public facing IP address. It's got completed. Let's go and create the other resources as we go along. If you're doing step by step, at the same time you can also create all the configuration within a single PowerShell one. The idea is to walk you through individual steps, but you can choose to do this all in one go. In a production environment, you won't be doing things like this. You'll be deploying that in a single pipeline. Just want to verify all the configurations as well as the virtual machines are done. As you can see, the virtual machines are created with the public endpoint. Let's do a quick check on the resources that got created. It has created a load balancer, the network security group, the 3 NIC cards for the virtual machine, and a public IP address for the load balancer. It also create a disk for storing the operating system, and a virtual machine 1, 2, and 3, and it also created 3 RDP public IP addresses so that we can log into this particular virtual machines to go and change the configuration. Let's quickly check what's in the load balancer. Let's go and check out the front-end IP configuration. The front-end pool is created. This is the public IP address of the load balancer. Let's go and check into it, and it has got these virtual machines that are attached as the backend pool. Let's go and check into it, and this is the load balancer rule that was created. As you can see, the health probe is called my health probe, and its monitors at the on HTTP at port 80, and the backend pool is made up of 3 virtual machines which we created, and the backend port and the front port are tagged to a port 80, and the public facing IP address of the load balancer is 52.146.56.164. So let's go and log into this virtual machines, RDP into the machine, and then do additional configuration to host the website. So for that we need to do RDP into the machine. Navigate to the virtual machine blade, click on connect. Let's click RDP, and then let's download the RDP connection. So we logged into the RDP console. Let's click X, and then it's going to take us into the remote desktop. Let's wait for a few minutes till the machine is rebooted. Once the machine reboots, make sure, let's go into the Windows PowerShell in the administrator mode. So once you have the PowerShell ready, let's execute these following commands. The first and foremost thing we have to do is we have to install the IIS onto these machines. While that is getting configured, let's wait for a few minutes. Once the install Windows feature to deploy IIS is completed, we will go and remove the IIS start page, and then we will add a new page which basically says hello world from the host. In this case, it's going to be host virtual machine 1. So by doing this, when we have the load balancer distribute the traffic to different virtual machines, it will help us to identify which virtual machine the traffic is landing, so that way we can demonstrate the concept of load distribution across multiple virtual machines. We have to go and do the same configuration of other 2 machines. I'll see you after I finish the configuration. So having configured all the virtual machines and changed the default IIS web page to our custom one, let's go and check what is the public IP address of the load balancer that we have just created. As you can see, the public IP address of the Azure load balancer is 52.146.56.164. You can always find this value by navigating into the Azure load balancer blade, but this is just an example of how to get the public IP through a PowerShell. So now let's navigate to the web, to the public IP, and let's see what you see on the browser window. Just to showcase, I have a couple of browser windows open. The first one is a normal window. The second one is incognito mode. So I've typed in the public IP address of the load balancer, which is 50.146.56.164. So that's it. Looks like the page is being served from the web server 3. Let's try this one and let's see where the page is coming from. It's coming from the virtual machine 1. There's also one more variation where we can do is we can run a curl command within the Linux bash shell, and then we can see from where the pages are distributed. It's another fun way of doing it. So if you type curl 52.146.56.164, it's going to show the server from this particular request is being served. So this brings us to the conclusion of the demo here. So the scripts are available for you to go and try it out, and also I've given you some introduction concepts about the Azure load balancer, in this case the public load balancer. So let me know if you have any questions. Let's meet during the next week workshop. Thank you.